Good morning, grade 3. I'm gonna start in the science subject, lesson 2, chapter 12, and let's please open together page 490. The lesson is about sounds, okay? We can hear sounds all around us. Different sounds represent different things around us, right? If you hear, for example, the sound of a certain animal, you would know from its sound that this sound refers to that specific kind of animal. So sounds around us give us clues about what we are hearing, right? So all sounds begin when something vibrates. Let's start about defining sounds. And sounds, whenever there's something you are hearing, that means there is something vibrating. Vibrating means to move something that move back and forth, okay, this way, back and forth, okay, means that the thing is vibrating. So vibrating, whenever there's something giving out sound, it means that this thing is vibrating, it is moving. So things that do not move, they might not give any sound. To make them give out sound, you need to vibrate them. So as I said, you cannot make a sound without making something move. Sound is a kind of energy that comes from object that vibrates. So object that vibrates may give sound, but things that cannot vibrate or things that are not vibrating or moving, they will not give sound. Now, let's move to the second point. Sound travels in waves too. So, you have to know that the sound traveled into waves. What are waves? If you take a look here in this picture, you would see that there is a boy using this instrument, this musical instrument, the guitar, I think. Okay, so the sound that is coming out of the instrument, it is moving into waves. It is moving into levels until it reach someone who's gonna hear the sound of this instrument. So waves are levels that the sounds are moving into them. Okay, now, so the sound wave moves through the air. This is what I said. So the air is a kind of gas. Okay, so you hear the sound when the sound wave reaches, of course, your ear. And this is what I said. So the levels or the waves that the sound is moving through them, they will reach somebody's ear that will let him hear what is the sound of this musical instrument. Okay, now let's move to page 491. On the second page, they are telling you that sound waves travel through air, gas, and solids, and even liquids, okay? Air or gas, okay? So air is an example of gas that sound waves might travel through. So sound waves travel through air, as an example of gas, liquids, and solids. Now let me show you on my laptop some examples of how certain sound waves might travel through, for example, let me show you how they travel through gas first of all. If you take a look here at this picture, you will see that there is an animal called a bat. This bat will communicate with another bat, okay, by sending out waves. Can you see the waves? So these waves will travel in the air or in the gas to reach another bat, okay? So here the waves are traveling in a form of or in a gas, which is the air. If you take a look here, you will see that animals living under the sea or in the water, like dolphins or any kind of fish, or any kind of creatures that live under the water, they communicate with each other, okay, by sending waves, and these waves will travel in liquid, okay? Now let me show you an example how sounds will travel through solid. You know this wire cup thing? Okay, this wire cup thing, if you speak through the cup, the sound will pass, or the sound waves will move in the wire, and you know that the wire is a kind of a solid, right? So here the sound waves are moving through the wire or moving through the solid to reach the ear of the other person. So here I showed you 3 examples how waves, sound waves can travel through air, as the first example that I showed you here, the example of the bat, through liquids and through solids. Okay? Now, sound waves travel through matter. So matter is a kind of solid, liquids, or gas. And this is what I said. Okay? Now, sound does not travel in space. If you go outer space, you cannot hear each other because there is vacuum, there is no air. Okay, so that's why there is no possibility to hear sounds from other things. Sound does not travel at the same speed through materials. You have to know that the sound waves that I showed you here, okay, they go faster in different materials. If I take a look, for example, they will pass very slowly, or the slowest in the gas, faster in the liquid, and fastest, yeah, it means they travel the fastest in the solids. Okay, so you have to know that sound waves travel in different matters, solid, liquids, or gas, and they travel the fastest waves travel in the solids, then liquid, then gas. Okay, it means you can hear things faster if they travel in solid, less in liquid, and the least through gas. Okay, let's turn the page to 492 and let's read the question. How are sounds different? Okay, of course, if I vibrate certain thing, or if I hit on a table, let's say, if I hit on a table or I knock on the door and somebody else came after me and he hits the door, I might hear the knocking of these 2 persons differently. Okay, why? Because sounds have different volumes. What does this mean? Volume describes how loud a sound is. So if you hear the sound loudly, okay, it means it has a big volume. And if you hear the sound with the low sound, it means the volume is very small. So loud sounds are made up by objects that vibrate with a lot of energy. That means the more energy of an object vibrates with, the louder the sound it makes. Now, let me explain this point and let's take a look here. Let's take a look at this drum. As I said before, that to give sound we have to vibrate things, right? So, in this paragraph, they mean that if you vibrate the thing more, or you vibrate it with a lot of energy, it means hardly, it's gonna give a lot of sound or a higher sound. But if you tap on this drum, you don't hit it hardly, you just hit it slowly with its sticks, it will not vibrate too much. That means a low sound gonna go out. So as much as you give volume, as much as you vibrate, hardly the more the volume, the more the sound is. As you vibrate slowly, the sound gonna be low. Okay? Now let's move to page 493. On page 593, they are talking about the pitch. Okay? A sound's pitch is how high or low it is. So whenever you are talking about how high the sound or how low the sound is, you are talking about the sound's pitch. Because the word sound by itself, it is an energy. So if you are talking how you are hearing this sound, okay, you are talking about the sound's pitch. Okay, so an object that vibrates quickly has a high pitch. It means a high something you hear. Okay, object that vibrates slowly has a low pitch. Okay, so slowly, slow vibration, low pitch. High vibration, high pitch. Okay, an object's length can affect the pitch. What does this mean? If I have something that is very long, okay, like this kind of table or this kind of a machine or a musical instrument, okay? So take a look here. The length, okay, of these kinds of keys that are that gives out music, okay, is very important. Why? As much as the thing is very short, okay, you're gonna hear the vibration, or you're gonna reach the waves faster, so higher pitch or higher sound pitch. As much as the thing is big, okay, the vibration will reach you with a more time. It means the waves are taking too much time to be received to you. That means the sound gonna be low. Okay, so the shorter, the faster vibration, the higher pitch. Okay, the longest, the lower vibration, the lower pitch. Okay, please, you have to know this. So let me give you another example. For example, take a look here. Okay, this kind of the cup wire thing. Okay, the wire that is attaching the two cups or the two bottles here, as much as I elongate the wire, okay, the sound gonna reach you low. As much as I make it short, the pitch gonna be higher. So the length of the thing that is transferring the sound waves is very important. Okay, did you understand now? I hope so. So the length, okay, is very important. Not only the length, but here they are talking about the thickness. So the thickness of an object can affect the pitch. So thin strings vibrate faster than thick strings. So thin strings have higher pitch. The same thing here. Okay, let me show you again to this example. If the wire that the boys are using is very thick, the vibration, okay, will be less, so less pitch. And if the string that the boys are using is very thin, it will vibrate a lot, okay? The more vibration, the higher the pitch is, okay? Let's move to the last page, which is 494, and let's read the question. How do you hear sounds? Of course, I said waves travel through matters and till they reach your ear. Okay, so first the sound wave is collected by the outer ear. So let's take a look here. This is the outer ear. So sound waves, first of all, they reach the outer ear, then they go to the eardrum. Okay, so let's move step by step. So the sound wave is collected by the outer ear. Next, the sound wave makes your eardrum vibrate. This is the eardrum here. So it starts vibrating because it's collecting waves, okay, from the outer ear. So first of all, sounds is reaching your outer ear, then vibration or the waves gonna go inside your eardrum. Your eardrum starts to vibrate. These vibrations pass through inner ear, okay, to the nerve, okay. So from the outer ear to the eardrum to the inner ear, something that is very deep in your ear, this vibration will be sent to something called nerves. The nerves, okay, will send these waves or this vibration to the brain. Why do they send it to the brain? They send it to the brain so your brain will recognize this sound and knows this sound is referred to what object, okay, or to what thing. So the nerves send a message to your brain, and then you hear the sound. And after you hear the sound, you're gonna recognize what is this sound for. Now, you have to know something, that you have to protect your hearing. And since the hearing is related to the ear by itself, you have to protect your ear. You shouldn't put anything which is pointed in your ear, and other things that can damage your ear is like loud sounds. So if you are hearing music or listening to music, don't put the sounds or the volume of the music very high, because it might damage your ear. Okay, and that's it for this lesson. Hope everything is clear, and please don't hesitate to ask. Thank you. Hi again. We're gonna move to lesson 3 and the science subject, and it's about light. Let's please open together page 500 and let's read the question on the top. What is light? You know that you can find light all around you, and we use light in our everyday life. Okay, you have to know that light is another example of energy. Okay, we talked about heat, we talked about sounds before. Now we're going to talk about light, which is an example of energy. Okay, the main important usage of light is to help us see objects, right? So light comes from many different sources, and you have to know that the main important source of light is the sun. Okay, I'm gonna show you other examples of light. Here we have, as I said before, the main important source of light is the sun. Also, light bulbs is an example of source of lights. Candles, flash lighters, and also fire. Okay, so these are examples of sources of light. All of these are used to light things around us. Okay, now, so you have to know that light travels away from a source in a straight path. So light travels in a straight path until it hits an object. Let me show you the pathway of a source of light. Here I get an example of a flashlight. You know the flashlight? This is a flashlight. Okay, so if you take a look how the light is moving, you're gonna see that it's moving in a straight line. It's not moving in a zigzag, or it's not moving in a curved line. No, but it is moving in a straight line. So the pathway of how light moves in is a straight line. It moves into a straight line until it hits something. When it hits something, okay, that's the moment when you can see that thing, because light hits it. Okay, so the main important point here that light moves through a straight pathway. Now let's talk about absorption. Light can be absorbed or take in. So when it hits with an object, if this object is very dark and black, okay, it will absorb all the light. Okay, that means you will not be able to see it through it. And if the object it is nearly white or very light in color, the thing that is hit by the light cannot absorb the light. Okay, so dark things absorb light, white things do not absorb it. Okay, let's move to page 501 and talk about reflection. If you take a look here in this picture, you're gonna see that if the source of light hits something, it might reflect it again in another direction. So when light hits some objects, it reflects or bounce off them. Bounce of them, it means go out of them. So when it hits here, this point reflects the light out of the thing. Okay, so sometimes light is reflected. Okay, now you see an object when light from the object reaches your eye. You see those objects when light reflects off them and goes into your eye. And this is what I said. So as this flashlight hits something, for example, I'm moving into a dark room and this flashlight hits my pen. So when this light hits my pen, I will be able to see this pen after the flashlight hits it. Okay, so this pen will have light now, then the light, okay, will be reflected from the object to my eye, so I will be able to see it. So this is what they are saying, that you see object when light reflects of them. So the light, okay, will go out of them to your eye, so you will be able to see the object. Let's turn to page 502 and let's read the question together. What happens when light hits different objects? You have to know that there are examples of objects that light might hit them. There's something called opaque objects. Okay, opaque objects block light from passing through them. These opaque objects can be examples of something that are made up of wood, something that is made up of let me show you here. I think I got one. I don't know why it's lost. Let me just get it quickly. So opaque objects block light. Okay, let me show you here on my laptop an example of opaque objects. Take a look here. This guy is holding a flashlight again. So this flashlight, okay, is directed to this wooden thing. If you take a look behind the flashlight, you will not see any light. Why? Because wood is an example of opaque objects. It will not allow the light to pass through them. It will block it and stop it here. It will not and let it go out to the other side. Okay? Now, let's go to something called shadow. Shadow is a dark space that forms when light is blocked. I will show you here an example of shadow. When shadow is formed, for example, this is the source of light, which is the sun. It's giving its light to, let's say, to this block or to this building. When this light rays hits this building, so this building actually it's blocking the light to pass through, okay? Not blocking it from this side, but it's blocking it from the top. So when it's blocking it from the top, something will be formed which is called the shadow. The shadow is another let's say it's not real, it's something that refers to the shape of the thing that the light is blocked by. Okay, so if it is rectangular, you're gonna see a rectangular shadow. If it is circular shadow, and like this. So whenever they tell you when light is blocked, okay, from things, that a shadow will be formed. Okay, now let's please open page 503, and we're gonna talk about transparent objects. Transparent objects allow light to pass through them, so you can see things clearly through them, like glass or plastic. Sometimes these objects can be translucent. Translucent, it means they are not very clear. Okay, they can be also glass or plastic, but they are not very clear. So you cannot see the things through them easily or clearly because light is not gonna pass through them easily. Let me show you an example. If I take a look here, these two cups, one it is transparent and one it's translucent, it's tinted. Okay, so this cup, it's very transparent, so you can see the thing inside it clearly. So light passes through it clearly, so it hits the object here and you can see it clearly. While light through translucent things cannot pass easily, that's why you can a little bit see the thing that is inside, but you cannot see it clearly. Okay, so this is transparent and this is translucent. Now let's turn to page 504. Why can you see colors? You have to know that the light that is coming from the sun is made up of different colors, and after it reaches us, okay, it reaches us by one color. We can see it as one color, but actually it's made up of different colors. We used a prism as a piece of glass that reflects light. So any kind of light that you see as white or yellow color, it's made up of different colors. For example, here, if you take a look, this is the kind of example of the prism. It is a piece of glass. If you pass the light through it from one side, it's gonna be reflected from the other side by different colors. So you know that this white thing, it's not made up of only one color of light. It's made up of a group of colors that make up the one color that you see. Okay, so the job of the prism is to separate the white color into all colors that makes up this white thing. Okay, let's go to page 505. You have to know that an object that absorbs all light that strikes it looks black. I will show you an example about what I'm talking about. Okay, where's that thing? Okay, here. You know that thing like a curtain in our home? It's called blackout. So this blackout is made up of black colors. So light cannot pass through them, so it makes the room very dark. Okay, we use it whenever we are sleeping in the morning. We close the blackout so light cannot pass through them. So usually things that cannot pass through light or cannot absorb or absorbs all the light and will not let it move to the other side, they are usually black. Okay, that's why we call them blackouts. Okay, let's move to the last thing here about page 506. And how do we see? You have to know that light that is refracted, it passes through different steps in our eyes to be able, that gives us the ability to see the thing. Now, I will show you here an example of the eye. Can you see this? This is the eye here. Okay. You have to know that the first step, the light, okay, enters our cornea, okay? This is the cornea, which is the outer layer of the eye. Here, can you see this arrow? Okay. After the cornea, it passes through the pupil. The pupil is the black hole here inside our eye. So from the cornea to the pupil, after passing to the pupil, which is the black opening or the center of our eye, it will go to something called the lens. Okay? So cornea, pupil, then the lens. Then after passing to the lens, it will go to something called the optic nerve. The optic nerve is not shown here. Okay, the optic nerve is shown in the book. It is coming near the brain. So from the cornea to the pupil to the lens to the optic nerve and then to the brain. Why does it go to the brain? The same thing as I talked before about the sound. It goes to the brain, so it gives you information about what you are going to see, okay, or what you are seeing. Okay, please, you have to know that first step, the cornea, then pupil, then lens, then the optic nerve, then to the brain. That's it for this lesson. Please don't hesitate to ask if there are any questions, and we are always ready to help. Thank you. Okay, but just the main point in lesson 3, I forgot to mention it before. It's about refraction. And refraction, it is when the light bends. And when the light bends, okay, it gives a look that the things that you are going to see as if they are broken. If you take a look here, the bending light or the refracted light here gives a look that the pencil is as if it's broken. Okay, that's the thing about refracted light. Okay, that's it. I just forgot to mention it before. Please pay attention. That means bending light rays make things as if they are broken. That's it. Hello. Now I'm gonna move to lesson 4 in the science subject, and it's about electricity. Let's please together open page 512. Okay, what is electrical charge? Okay, now I'm gonna start explaining the meaning of electrical charge. Electrical charge is a property of matter. You cannot see electric charge. You have to know something, that anything around us, anything, the pillow, the table, anything has electric charge. Okay, inside it there is something that you cannot see that makes up the charge of the stuff or the thing that we are talking about. Okay, so anything has electric charge inside it, which make it neutral or has a certain electric charge. Okay, I will show you now what do I mean by electric charge. Take a look here. Imagine that these are two things. These what are inside the things that you cannot see in your naked eye, okay, are called the electric charge. They are made up of positive and negative charges. Okay, so These negative and positive charges, okay, makes up at the end the charge of the thing that is around us, okay? So there are two types of electric charge. One is called positive and the other one is called negative, and this is what I showed you in the picture. An object with positive charge pulls an object with negative charge. Object with positive charge push things that are made up of positive charge. So you have to know something, it's like magnet, okay? So let's go back to this picture. If I count the positive charges in this thing, let's count them, 1, 2, 3, okay? And let's count the negative charges of this of these charges inside this thing. So 1, 2, 3, 4, 5. So we have 5 negative charges besides the 3 positive. So since the negative charges are more than the positive charge, then this thing has a negative charge because the number of negative charges are more than the positive. If I take a look on the other thing, I will count the positive charges. They are 1, 2, 3, 4, 5. Besides, I have 2 negative charges only. So this thing has a positive charge, since the positive charges are more than the negative ones. Okay? So this one is negative and this one is positive. So the thing that gonna happen here is that they're gonna come next each other or gonna attract each other, okay, since they have opposite charges, one which is negative and one which is mostly positive charge, okay? You have to know something. If a certain thing has the positive charge, that doesn't mean inside it only positive, but what it means that the positive charges are more than the negative, okay? Let me show you something here. You have to know that, okay, if certain thing has more positive charge, it's gonna attract a certain thing with more negative charge, okay? If these two things have positive charge, they're not gonna attract each other. The same thing, even if these two things have negative charges, they will not attract each other, okay? What about if the charges in certain things are with the same number of positive charges and negative charges? This thing has a charge which is called a balanced one. So when the number of charges of positive and the number of charges of negatives are equal, it means, let's say 4 by 4, okay, then this thing is called balance, okay, neutral. So it's neither positive nor negative, okay? Let's move down. A buildup of electricity charge is called static electricity. You have to know something, that the charges move inside this thing and they move from one thing to another. For example, I will show you here an example of static energy. Please, you have to memorize this. A build up of electric charge. So when build up, it means when these charges build up from one thing to another, move from one thing to another, they make a static electricity. Let me show you here an example of static electricity. Okay, take a look at this girl. Okay, this girl got a balloon. If you tried this experiment at home, if you have a balloon and you rub the balloon with your shirt, okay, you are building a static electricity. Why? Because the charges inside your shirt, okay, and the charges that are inside the balloon starts to move between each other. So the negative charges in your shirt will move to the balloon and make the balloon with more negative charge. So now the balloon has a negative charge. If you get this balloon near something with very positive thing or something, let's say, neutral, it will try to attract it because it is very or it's highly negatively charged. Okay, so this is called static electricity. Okay, when the charges are built up between two things. Okay, now let's move to page 514 and move to the word which is called electric current. You have to know something, that in our home we have lights, we have certain things that give us fire, sounds, anything that gives up something at the end. Sometimes it's using electric current. So electric current is a flow of the charged particles. So when the charged particles, they move in a certain current, we call it electric current. This electric current at the end, it's gonna build up an energy that gives us light, maybe motion, maybe sound. Okay, I will show you here certain things. Okay, for example here, in order to cook on this electrical stove, okay, you need to put this stove in the electricity. Why? To build up an electric current so it gives heat. The same thing here for the light. This lamp, okay, needs to be put in the electricity to make electric current. Okay, so this lamp or this this lamp at the end gonna give us energy in the form of light. The same thing for the computer, it needs electric current to start working. The same thing for the blender here, in order to start working, it needs electric current. So electric current gonna build up energy in different forms. Sometimes energy in the form of light, energy in the form of heat, energy in the form of moving. Sometimes it gives sound, whatever. So this is electric current. At the end, it builds energy. Let's move to page 515 and let's talk about a circuit. A circuit is a path that is made of parts that work together to allow the electric to flow. So there is something you have to know, that in order for the electric current to pass, okay, there is something, it passes through a circuit. Take a look here. Imagine that this is the lamp that I showed you before, the big lamp. Okay, it has this light bulb. It needs to we need this light bulb to give us light. Okay, so the source of energy here that I'm using is the battery. So the moving of the current from the battery to the bulb, in order for the bulb to give us light at the end, this is called an electric circuit. Okay, so sometimes the electric circuit doesn't give us energy at the end. It means that there is something wrong in the electric circuit. So the simple electric circuit has a switch. Switch, it means like the buttons you press on the wall to turn on the light and to turn off the lights. Okay, so here is the switch. Imagine that you press the switch to turn on the light. What's gonna move from the battery? It is electricity, okay, or electric current. So the electricity gonna move and it's gonna pass through the switch, and then it's gonna move to the bulb, and after that the bulb gonna turn on and give us light. Okay, so this is called an electric circuit. So a complete unbroken circuit is called closed circuit. So whenever the circuit gives us energy at the end in the form of light, sound, heat, whatever, okay, it is called a closed circuit. So when the current or when the electric current, when the electric circuit, works, it is called a closed circuit. Okay, why it is called a closed circuit? Because the switch here, it is closed with the wire. Okay, it means that the electricity can pass directly to the bulb. Okay, if the switch is open, let me show you electric current with open switch. Just 1 second. With open switch. Okay, take a look here. This is the switch, okay, and this is the battery. If the electricity is gonna pass by, okay, and the switch is open, there's something broken here or something that is not complete. So the electric current not gonna pass to the bulb, and that's why the bulb not gonna turn on, and we're not gonna have light. Okay, so you have to know something. When the switch is open, okay, there is no current or there is no energy at the end. Okay, if they ask you in the book a switch, or what is the thing that allows us to control the flow of the current, it is the switch. What I gave you the example of the switch as the thing that the button we press on the walls. Okay, so when a switch is on, okay, there is no gap. Okay, so the path is complete. When the current is closed, a current can flow. So you have to know that when the circuit is closed, it means it is a complete circuit. So at the end we're gonna have energy. So if the switch is off, it means it's open. So there is a gap. So there's not gonna we're not gonna have any circuit, and there's not gonna be any current flow. Okay, and that's why the bulb will not turn on at the end. Okay, let's move to the last page, which is 516. You have to know about two things that can pass electricity and things that cannot pass electricity. We have two kinds of materials that conduct or allow the current flow to pass by. We call them conductors. And materials that do not allow the flow of electricity are called insulators. So two kinds of materials. One that allows the pass or the flow of current, and the other one do not allow, and the other one does not allow the current to flow through it, and it's called insulators. Let me show you some examples of conductors and insulators. If you take a look here about conductors like wires, gold, copper, iron, so anything that that is made up of metals are conductors. What about insulators? Insulators can be papers, plastic, wood. So anything that is made up of plastic, paper, wood, it is an insulator. It will not pass through it any current, and conductors pass through its current. So here, if I put a conductor at the end, I will feel the electricity. Here at the end, there's no electricity. Okay, that's the end of this chapter. Please, if there are any questions, don't hesitate to ask. Thank you.